Hello everyone. In this video, we are going to discuss about blood flow measurements. So that is how the blood flows through inside the body and how the movement of vessels absorb the blood and if there is any discrepancy how it has been identified. So all those things we will be discussing in this video. So let's now move on with the video with blood flow measurements. So actually, the blood flow measurements is used to indicate how much amount of blood flows inside the organs. So if there is any improper blood supply, it would result in various diseases and diagnosis could be done based upon the amount of blood flow received in the blood vessels. So Asian methods like turbine flow meter and rotometer, which are not suitable for the measurements, since because these measurements involves in cutting of blood vessels. When they are about to measure the blood flow in the vessels, so some of part of the blood vessels has to be cut. So in such a way that these methods have not been now currently used now. So some of the basic types of blood flow meters are magnetic blood flow meter, Doppler shift blood flow meter, radiographic blood flow meter, indicator dilution method, NMR blood flow meter, laser Doppler blood flow meter. So let's now discuss about in this video we are just going to discuss about the magnetic blood flow meter and Doppler shift blood flow meter and how it is working and its corresponding types. So let's now move on with the first type, which is the magnetic blood flow meter. So the magnetic blood flow meter basically it works upon the Faraday's law of electromagnetic induction. So whenever a current carrying conductor is placed inside a magnetic field, so it gets induces an voltage and that voltage which has been produced will be directly proportional to that of the velocity of its motion. So basically the electromagnetic energy or the induced voltage when a blood vessel has been placed inside a permanent magnet, it is given by E equal to CHVD, where H is the magnetic field. Since the blood vessels has been placed inside a permanent magnet, V is the velocity, and D would be the diameter of the blood vessels, and C is nothing but the constant. So the first picture, let's now see it in a diagrammatic view. So the first picture represents how the permanent magnet has been placed and inside that permanent magnet how the blood vessels has been rotating and it induces an voltage or an electromagnetic energy which is termed as to be the E. So how this blood vessels along with the magnet works? So this is a procedure how this electromagnetic uh, blood flow meter works. So it consists of an oscillator, a gate, and a filter. So the oscillator is used to drive the gate terminal, and so whenever the pulses have been produced by the gate terminal, so the gate is responsible for indicating the direction of the blood flow. If the pulses are reversed, it means that the blood flows in the opposite direction. If the pulses are in the positive direction, it means that the pulses flows in the normal order. And if any discrepancies or noise has been added in the pulses, it gets filtered out by the low pass filter, and finally the average pulse has been obtained at your output. So this is how the magnetic blood flow meter used, and this is also one of the Asian method of the blood flow meter. Let's now proceed with the second type of blood flow meter, which is ultrasonic blood flow meter. So, as the name indicates, ultrasonic blood flow meter, here ultrasonic energy is going to be used, and here the velocity which is flowing through the blood, could be determined with the beam of an ultrasonic energy. So, basically, there are two types of ultrasonic blood flow meters: transit time ultrasonic and Doppler shift type ultrasonic. Let's now discuss in each and everything in detail. So let me first proceed with the transit time ultrasonic blood flow meter, and this is how the transit time ultrasonic blood flow meter. Here the ultrasonic energy has been allowed to pass through the transducer, and this transducer is an ultrasonic transducer, and this has been placed at a shallow angle of theta, and d is going to be the distance between the transducers, two transistors, one is for the transmitter, other one is for the receiver, and d is going to be the distance between the two transistors, and the two transistors are placed at an angle of shallow angle of theta. So if the transit time is small, which means that the blood flows in the same direction. If the transit time is high, it means that the blood flows in the reverse direction. So the transit time could be determined by the formula distance by conduction velocity. So distance, here we have distance between the transducer is taken as to be the c, and the conduction velocity is given by c plus or minus u cos theta. Cos theta is nothing but the angle how it has been, the transducers has been shifted. So, depending upon the time, the blood flow indicates how the blood flows, whether it is in the positive direction or in the reverse direction. So, next we'll move on with the second type of blood flow meter, which is Doppler type ultrasonic blood flow meter. Similar to that of transit time blood flow meter. So here also we'll have a two transducers. One is for the transmitter, the other one is for the receiver. So whenever the ultrasonic beam of energy is sent towards the transmitted ultrasonic transducer, so part of it energy is gets scattered and it is going to be absorbed by the second transducer, which is nothing but the receiver transducer. So along with the blood flow, there is an frequency called FT. FT is nothing but the Doppler frequency which flows along with the blood flow meter. So here, if the blood flows in the same direction, it gives a frequency of F plus FT, and if it flows in the opposite direction, the frequency would be of F minus FT. So the Doppler frequency is given by Ft. Ft is equal to 2 F naught U cos theta by C, where Ft is the Doppler frequency, U is the velocity, C is the velocity of the sound, and F naught is going to be the input frequency. So let's now see experimental setup of how this Doppler frequency is measured. So this is an experimental setup how the Doppler type of ultrasonic blood flow meters are measured. So here we'll have a blood flow where do we have your two transducers. Whenever ultrasonic energy has been sent to the transmitter transducer, part of it gets scattered and it is absorbed by the receiver transducer, and that receiver transducer is allowed to pass through the detector, and from the detector will accept the signals of F plus Ft and F minus Ft, that is whether the blood flows in the same direction or in the opposite direction, both the signals it gets accepted, and the detector detects only the Doppler frequency and sends only the Doppler frequency, and that value of the Doppler frequency could be measured with the help of the frequency meter, which gives us the value of Doppler frequency, which is noted as to be the Ft. Yes. So in this video, we have just discussed about blood flow meters. That is, there are two different types of blood flow meters. Uh, we have discussed about two blood flow meters: electromagnetic blood flow meter and ultrasonic blood flow meter. In ultrasonic, we have come across two different types: transit type and the Doppler type ultrasonic blood flow meters. So blood flow meter is used to indicate or measure the volume of blood flowing through the blood vessels. Thank you, everyone.